girls! Today we want to start with the last part of our important lesson, lenses. We only have very small size, a very small part of the lesson. We will finish it quickly. Then I will solve with you some questions from paper 2. Then we will see what we will do. Let's start. Yesterday, when we talked about lenses and the application of converging lens, we said we have a case that when the object is between the principal focus and the center of the lens, it means that the object is very close to the lens. What we have in this case, we have a virtual image at the same side of the object that is enlarged, larger than the size of the object, and what also it is, we said virtual, enlarged on the same side and upright. When do we have this lens? We use it in magnifying glass. Today we want to talk about magnifying glass. At the beginning, now the apparent size of any object depends on two things. It depends on the actual size of the object and the distance, the actual size of the object and the distance of the object from the eye. Okay, so the apparent size, it's the normal size for any object. It depends on these two factors, the actual size and the distance from the object and the eye from the eye of observer. Okay. Now, magnification by a converging lens. Here I have an example of a converging lens. I put the object close to the lens in the focal length. Okay. Now, small object placed very close to convex lens. Okay. We said here, if you draw the ray diagram, you will see that the rays, they will not meet at all at this side, but the extended lines of these rays at the same side of the object, they will meet and they will form virtual, upright, and enlarged image. Image of object is highly magnified and on the same side as the object. So you are here. This is the magnifying lens or magnifying glass. Here's the object, for example, the book that you want to read, the object that you want to see. You will see, and if you are using a magnifying glass here, you want to read a book, for example, with a small font. You use it. You are here. Your eye is here. The book is here. You will see the image here. You will not see it on the same of your side. You will see it at the same side of the object, and you will see that it's very big and upright. Okay, not upside down. Now, you remember we said this note before, that the fatter or more curved converging lens is, it means that shorter, the focal length is what? Shorter. The principal focus is what? Closer to the lens. It means that more, it magnifies more, okay? So it's better for the lens to be what? Fatter or more curved. But not too much curvature, because too much curvature, it will cause what? It will distort the image. This is the meaning of distorts the image. Look here, the lens, if you make it fatter, it's better, but not too much, okay? Because it will distort the image. So fatter converging lens, it means it's better and it will magnify the image more. That's all for our lesson. Girls, we're done with our lesson lenses. You have put for you 2 links for 2 YouTube videos. They are very helpful. They will help you to understand the concept again and again, and they will help you how to draw a ray diagram again and again. Please watch them before we start solving paper 4. Okay, they will help you so much. So now, let's start solving some questions from paper 2 together. The first question, the ray diagram shows how an image is formed by a converging lens. What is the focal length of this lens? They want you to find the focal length. Again, what's the meaning of focal length? It's the distance between the center of the lens and the focal point or principal focus. Here we have so many distances. I have 24, I have 10, I have 8. But remember, we said before, if you have an object in front of the lens, we have two rays leaving or emitting from the object or going toward the lens. One of them is parallel to the principal axis. Then when it reaches the lens, it refracts and passes through the principal focus. So for sure here is the point for the principal focus. So what's the distance for the focal length? It is 10 centimeter. This is how we know the answer. So the answer is what? B, 10 centimeter. The second question. A parallel beam of light falls on a converging lens. Which diagram shows what happens to the beam of light? We said this note at the beginning of the lesson. We said when rays reach the lens parallel to each other, what will happen? All of them, they will meet at one point. What do we call this point? Principal focus. So the answer is D. In the diagram, the distance OP is the focal length of the lens. Through which point will the ray shown pass after refraction by the lens? So here is the lens. I have this ray. Remember we said before, here is the focal length. So it means this point is what? The principal focus. Okay? We said before that one of the three rays, if it passes through the principal focus from this side, when it reaches the lens, what happens to it? It refracts parallel to the principal axis. Go back to the lesson and watch the video again. You will remember this note. So it will pass through A. Okay. A student draws three rays of light from point P through a converging lens. Each point labeled F is a principal focus of the lens. Okay, so here F and F, the two principal foci of the lens. Which of the rays are drawn correctly? Let's see. You remember the three rays? One of them is parallel, then pass through the principal focus, so ray X is correct. One of them is straight, passes through the center of the lens and continue moving without refraction. Okay, this one is correct. The third one passes through the principal focus, then it refracts parallel to the principal axis. So this one is wrong. Ray Z is wrong. So which of the rays are drawn correctly? X and Y. The answer is C, ray X and ray Y. Which diagram correctly represents rays of light passing through a converging lens in a camera? We have here cameras, okay? Remember, when we talked about applications of a converging lens, we talked about camera and the lens in our eyes. You remember what did we say? In which case we have, which lens we have? The first case, when the image is smaller, real, smaller, inverted. Okay, so which one is the correct answer? This is the correct answer, A. Smaller size, inverted, and what also? Real image. So the correct answer is A. Also, go back to the video, watch it again, and remember what I talked about cameras and the lens in our eyes. Which statement about a converging lens is not correct? Always in these questions, read the answers one by one. The first answer, they want which one is not correct. A ray parallel to the principal axis of the lens is refracted through the principal focus. Yes, always we said that. Here's the lens. A ray that is parallel, it will refract through the principal focus. This one is always correct. All rays of light refracted by the lens pass through the principal focus. Is that true? All the rays refract by the lens, they meet the principal focus. This only we have it if they are parallel, not always. You remember we have a case when the ray pass through the principal focus, it will refract parallel to the principal axis. So this one is not correct. The answer is B. But let's read C and D to make sure that they are correct. The distance between the center of the lens and the principal focus is the focal length. Yes, that's true. This is the definition of focal length. The principal focus of the lens is a point on the principal axis, and yes, this one is correct. The principal focus, it is on a principal axis. So B is not correct. The diagram shows a converging lens forming an image of an object. Which statement about the image is correct? Okay, let's together look at this case. You remember this case? This is the case for a magnifying glass. We only have one case here, on the image at this side. So, you remember the properties of this image? What are they? Upright, larger than the object, uh, virtual, and what's also the same side as the object. Let's see. It is real, for sure no. I will not continue reading from the beginning. It's written real, it's not real. It is real, also this one is wrong. It is virtual, okay, it can be seen by an eye at X. Here is the eye at X. No, for sure no. How? You are here. This is the magnifying glass. Here is the object, the book, for example. While you are here, you will see this. But if someone is standing here behind the book, how they will see this image? For sure, no. So the answer is not X. The answer is Y. It is virtual and can be seen by an eye at Y. Yes, that's true. The answer is what? D. Which labeled distance is the focal length of the lens? How do you find the focal length? You remember? When parallel rays they move toward the lens, then they all refract and meet at the principal focus. So B is the focal length of the lens. For sure not D, for sure not C, because the rays they are not coming parallel. Only when they are coming parallel they meet at the principal focus. And here also for sure it is wrong. That's all for today. That's all for today, girls. You have these questions. They are homework for tomorrow. The same as the previous time, I will choose randomly the girls that are going to answer these questions tomorrow. So please, all of you, try to understand and to solve the questions by yourself. Thank you, girls.